Hi, my name is Lindsey Applegate. I work with Dr. Tori Forbes in the chemistry department here at the University of Iowa. And today we're going to talk about the efforts to remediate uranium contamination in the American Southwest. So first let's talk about what uranium is. Uranium is a radioactive element that can be found right down here at the bottom of the periodic table. And it can get into the environment via old uranium mines. And the reason why this is a problem is that if it gets into the water supply for people in surrounding areas, it can cause a myriad of health issues. So people who live in these areas suffer from diabetes, hypertension, birth defects, and a range of other things. So it is really very important to be able to remove this from the environment for the good of the health of the people in the surrounding areas. So these abandoned uranium mines that we're looking at are in the Four Corners region of the American Southwest, and you can see that on this map here on the left. So this is the region where Colorado, Utah, Arizona, and New Mexico intersect. And looking here on the map, each red dot represents one uranium mine. So you can see that there are a whole lot clustered in this area. And if you look here at the associated graph on the right, you'll see that out of 521 total mines, over 77% of them have radiation levels more than 2 times above background. And there's a pretty great amount that's over 10 times above background. So this is a huge problem. And also looking here, if you see this yellow area outlined on the map, this is the boundary for the Navajo Nation. And we can see that most of these uranium mines are within this boundary. So these Navajo people are disproportionately affected by this problem and at a special risk for these health issues. So what our group is aiming to do is to detect and subsequently remove this uranium from the environment. But first we have to understand how it interacts with other things in the environment so we can really understand how to do this. So looking at this figure on the left, we have just a depiction of uranyl, which is a form of uranium, in the groundwater. And what we want to do is be able to get it to interact with this material that we've made in collaboration with the engineering department here on the right. And if we really understand the interactions that uranium has with other chemicals, we can understand how to optimize the interaction with this material, detect and remove the uranium. So what we're looking at is we're looking at the interactions with citrate. And citrate is just another form of citric acid, which is what we find in our orange juice. But citrate can also be released from the roots of plants in nature. So once that citrate is released into the environment, we have both citrate and uranium in the environment readily able to interact with each other. So what we want to do is we want to look at environmentally relevant conditions and see what really is happening and what promotes those interactions with citrate and uranium. So what we've seen in our research is the formation of these large clusters when we have citrate, uranium, other things found in the environment under environmental conditions. And what the good thing about having these clusters is that we can really study them and we can characterize them so we can see how they behave and how they form. And it will also help us identify different forms of uranium during detection so we can really understand what's going on. So in the future, we're going to look at trying to form similar clusters with other chemicals found in the environment and also use other methodology to really be able to understand both this and future clusters that we form. And then we'll apply that knowledge to those materials that we talked about a little bit earlier to be able to detect the amount of uranium in the environment, understand the hazard, and then remove it and make it a safer place to live for the people in that area. So I couldn't do this alone, of course, so thank you to my PI, Dr. Tori Forbes, grad students, undergraduates, collaborators who have worked with us, and the National Institute of Health for funding, and of course the University of Iowa for their support during my graduate career. And if you have any questions, you can feel free to contact me at that email down there on the left. Thank you, and thank you for your time and attention. Have a great day.